today, end of the day, we will be covering CQL. In module 6, we have learned about integrating Hadoop and CQL. Now, first of all, when they have Thrift API, what is the necessity for them to come up with something called CQL? When they already have Thrift API. Actually, Cassandra implemented Thrift API first, and with the gained popularity of and lot of feedbacks from the lot of business users or lot of Apache users, this Apache Cassandra users, they started implementing CQL. So, but reason behind it is Thrift API is meant for only Java people. Am I correct? So it doesn't give you an easy way to communicate with your Cassandra other than Java. That is a reason. That is a basic reason you can think like, you know, people started asking Apache Cassandra team, why can't we have some other tool which can give SQL-like syntax on top of your Cassandra client or Cassandra, so that it becomes easier for adopting it. That is a basic reason why they started implementing CQL. Okay. Now, most important is SQL, because CQL is also similar to SQL. It also provides lot of functionalities which are provided by SQL. But I just want to tell you, it is subset of SQL 92. It is subset of SQL 92. You can't say that every SQL function is available within your CQL, but it is, if you know SQL, to learn CQL, it doesn't take much time. That's it. Okay. The learning time or adoption time is much faster, because CQL is meant to be as a database, first thing, and also to get served as a different front ends through which they can connect and read the data. That is the reason they want to provide a SQL type sort of interface on top of your Cassandra. Okay. And it is very common, simple, easy to understand as well. So let's assume that this is your Cassandra ring and this is your Hadoop cluster. So the pig is running here to pull, after pulling data from here. But what about your front end? If you look at pig, it is using MapReduce. Anytime MR is slower, latency will be higher in case if you use MR. Am I correct? So, but for my front end, I want more faster responses from my Cassandra. So actually CQL fits here. Not here. As I said, CQL and your as well as your Cassandra client or a Thrift API, both through which you can communicate to your Cassandra cluster and get the data with a very low latency. But if you want to do any analytics on top of your Cassandra data, then you connect to Hadoop cluster and you pull the data, or using standalone whatever we just discussed till now, and then run MR to calculate data. But MR is meant here to do large volume of data processing. CQL here or a Thrift API here is to retrieve a smaller subset of data which is required for the front end to be populated. Though I am repeating for the benefit of everyone. Okay, so let me further move on. The way you have Cassandra also different version, even CQL also has got a different versions. Okay, I just want to let you know CQL right now approximately I worked with only majorly 3 only. If I'm not wrong, it is 3.4 also its latest version. If I'm not wrong. Okay, I think they're releasing even 4 also. I think. Oh, sorry. DSC 4 it released, but with the CQL 3.4, I think. Okay. Anyhow, just to let you know, Cassandra 2.0 uses CQL version 3.10. But I just want to show you here. If I say CQL sh, can you guys see here what is the version it is using? It is using 2.0.0. It's not 3.0.0. But in case if I want to use CQL minus 3.3 version, you just need to say CQL sh minus 3. You could see here it started using spec of 3.0.0. So based on, see here CQL spec is different and CQL shell is different. CQL shell is same, but the spec it is different. Based on the spec, the type of command or the command which you are going to give makes a difference. I just want to make it very clear. Okay, some of the commands which are available in this is not available here, or they are altered to be more user friendly to provide those commands. Okay, so whatever I'm going to use or give commands for CQL, I'll be aligning to a CQL version of 3, not 2. Okay. How come your Cassandra is able to read and write faster? First thing, it is not a B tree, which is in general in RDBMS. It uses B tree. Here it is a map, hash tree. Okay. And then the data is distributed across the cluster. Okay, some nodes or few nodes, not just some nodes. I would say it as like based on your key space, based on your values, it gets spreaded across multiple nodes. Data gets spreaded across multiple nodes. That is also another reason. But most important is we compromised on the consistency. I'm repeating, because we compromised on the consistency to gain the availability, it becomes faster. Because we compromised on the consistency, and that is the reason it becomes as a faster. But there is also one more thing which is most important. It is using not just only the factor of data, what we just discussed, data gets written to multiple nodes, and you have consistency compromised, and all writes are irrespective whether delete or insert, everything it is called as upserts. So because it's using a technique of upserts, it becomes faster. And the last but not least, which is also very important, is it is using the hash maps. It is using the hash maps or a sorted maps. So that is also another reason compared with B-tree indexing when you look at your RDBMS world. Okay. Okay. Now data writing whatever gets to writes to Cassandra cluster, you have a highly availability because the data is written, replicated, as well as there is no master and slave architecture. It is peer-to-peer architecture. That is also another reason. You can imagine like your writes are faster. And as we said, it is upserts, nothing but all writes in Cassandra are appends only. And then writes in Cassandra are always atomic, because I just want to tell you one more important thing which makes a difference from RDBMS to Cassandra. In Cassandra there are no transactions, but in RDBMS there are transactions. To gain the transactions, Oracle or SQL Server or any other database RDBMS, it takes a lot of time when you are inserting data. But whereas because there are no transactions altogether, so because of that particular reason, it can become it becomes faster. Okay. Now, how come your reads are faster then? Because it is a hash map and it's not a B tree to retrieve the data. And second thing is the data is also available in mem table. So it is in memory and as well as in your cache. Whichever is there in SS tables, then it has got a bloom filter through which it can easily or quickly scan over multiple files and identify whether the data exists or not very quickly. That is the reason your reads are faster. Okay. The next comes the consistency level. What is consistency level? You can tune the consistency level so that your availability is trade-off. Okay. If you go for highest consistency, then availability is poor. If you go for lowest consistency, your availability is high. Okay. And when you say consistency in this scenario, the consistency is nothing but because you are replicating multiple copies of data for fault tolerance purpose to ensure that all replicas are holding the same data or same copy. Okay. Sometimes based on the consistency level what we configured, there is a probability that few nodes may respond saying, you know, old information, and few nodes may respond with a newest information or updated information. In that scenario, I'm so sorry for that guys. Okay, in that scenario, Cassandra will take care, and while reading, it will ensure it will read a latest value and give it to you. That is based on the timestamp. Clear, guys? There are consistency levels at two different levels. One is at a read time as well as a write time. The consistency level you can set at whole cluster level as well as your key space level, as well as your at the time of writing as at the time of your reading level as well. Clear? So indirectly what? If you feel that a particular row needs to be persisted at any cost, then you can go ahead and increase the consistency level, and then it will make sure that it gets written for perfectly, accurately. Okay? Now, as we said, consistency levels types are there, multiple types are there. One is 0, many, any, and quorum and all. I just want to show you from the code rather than just talking about, you know, by slide. Anyhow, we discussed all this in a, though is not part of slides covered, I have talked about all this to give more clarity. Am I correct, guys? So, but it, you know, it's just that it's coming in the slides right now rather than earlier at which time we covered. So, but I just want to show you in the code. Maybe I'll go for module 7 project itself to open. So you could see here, oh, it's not mentioned. Okay, no problem. I'll write one small code by tomorrow and then show you that as well. No problem. Okay, guys. Okay. Anyhow, so I think maybe there that particular code. I don't think I would have missed this. Yes, you could see here prices. I'm trying to give the consistency level as 1. Am I correct, guys? The 1 here consistency refers to when I'm actually inserting the data, I can give multiple values. You could see here all, any, each quorum, local quorum, 1 and quorum, 2, 3, 2 different values, 3 different values. But you could see here, we didn't talk about each quorum and local quorum. Am I correct, guys? So the each quorum in the sense if you have multiple data centers, then every data center should maintain its own quorum value, and that particular value has to be met at every data center level. And when you say local quorum, you don't bother about the other data center, you're bothering about only the present data center where exactly you're inserting data, and at that particular local quorum, what's supposed to be number of value. So don't forget guys, at the time of read, we don't have 0 and any, we have only 1, quorum and all. When you say all, it reads data from all nodes, and that gives a flexibility for you to do a read repair at that time. Okay, if you go for quorum to have a consistency perfectly, what you need to do, your cluster replication factor by 2 plus 1. That's supposed to be your quorum value as a minimum. Okay, and then when you say 1, it will listen to from one particular node and it will return the value. If one node or one replica responds in the ring, that itself has a return. If you go for 1, if you assume that you're while writing, the consistency level is being set as all, and at the time of reading, then only you can set it as a 1. Or else you need to ensure that you should go with a quorum minimum until and unless you are very sure that your data has been written with a consistency level all, you can't read it with a CL1. If you read it, you may receive the data, but there is a probability that it may end up with a incorrect value while you are reading the data. Okay. So going to the write consistency level, again 0, any, 1, a quorum and all. What is the difference between 0, any and 1? That is most important here. Okay. So when you say 0, okay, so what will happen is, it doesn't even bother whether your commit log also received this data or not. It just tries to initiate the thread of writing the data, and then the client will get response saying that, you know, it's been initiated. That's it. So when you go for consistency level 0, there is a probability that all the total write may fail. So it's not a good idea to go for write consistency level as 0 until and unless if you feel like, you know, let's consider like Facebook likes on a particular image. I'm not bothered so detailed. In case if I end up with one value incorrect, I don't bother. In those scenarios only I can go for 0 as a consistency level, or else for sure I should have any one quorum or all. Okay. The next comes any. When you go for any, at least one node should have the data or should write the data. But it has to be in the commit log. It need not to be in the mem table. I'm repeating, any one node writing the data into the commit log will get a client response saying that data has been written. But when it comes to 1, it has to be written in both commit log as well as in your mem table in at least one node. Okay, the both are one node only, but it's just that any is response back if commit log is successful. Okay, but one response back until it will wait until it's been updated into the mem table, then only it will reply. Okay, and the quorum as is, as we discussed, it is replication factor by 2 plus 1, and then all is nothing but all replicas has to be placed before it returns to the client. Whatever you see, triggers and then functions, these two concepts are newly introduced to CQL. It's very primitive and it's for only testing purposes. Please don't introduce into your production-based systems. It is only for the purpose of, you know, you should wait for at least a year span to make that particular trigger as well as your indexes, not indexes, sorry, triggers and functions to be more foolproof before you start using it. So that's the reason intentionally I didn't include any demo for it. I want you guys to try, no problem. But again, I'm repeating, please don't include or don't develop triggers as well as your functions within your Cassandra cluster. Okay? But with that note, I'm proceeding further. With the Cassandra 2.0 onwards, triggers as well as your functions came into picture. The functions has got, token, time uuid and blob conversion functions. You have 3 different types. And triggers, the name itself represents that trigger is generally what it is, guys? A trigger, what exactly it is? If you want to drive something, let's say for example, you receive some data saying like, let's say you're reading from the sensor data. If the sensor fails, then it may send some data that it's a failure. So based on that, you want to understand and see or report to someone or bring into notice of some other people so that they can fix it. So rather than waiting to process the data, what you will do is on the table you will create a trigger. That trigger, what or nothing but on the key space, sorry, not key space, on the column family, you will create a trigger. That trigger will keep checking as and when the insertion happens to your data, and then that trigger will get triggered for every row, and based on your criteria you can fill another column family. In this scenario, into whichever you want to report it. Let's say for example, if this particular item is failed, or this particular electronic item, or this particular sensor, or this particular camera is failed, that event gets redirected. In case if you want it, then you can redirect it to the corresponding support team. You can think like that. So, or you can do building of an index, or you can do any other stuff which is like normal RDBMS trigger, you can think like, but it is a trigger on top of your Cassandra database on a particular column family. To create a trigger, you just need to say create trigger name on whatever table using a particular class. That particular class contains all the code what it's supposed to do for that particular row. Whenever there is an insertion for a row, it will create or it will invoke that particular class, and it will read or whatever it's been defined in that particular class, it will do it, and then it will come out. And please don't include triggers as well for another one more reason, because it gets called for every row key insertion. So then there is a probability that you may end up as long consuming process. Your performance may degrade at the time of writes because you're doing some other activity as well. Okay? So as I said, triggers are useful that you do some extra validations, or replicating some data from one table to another table, or incrementally updating the materialized views from one to another tables. Okay, then logging of any mutations that meet the particular condition. Just now I said like if there is a failure of sensor, reporting to somebody, you can it falls into the category of logging of any mutation that met a particular condition. Okay, implementing alerts and notifications, that also comes into this particular category itself, and performing any other specific logic. Okay, but as I said, it is not advisable to use even in the development systems at this point of time, because triggers are at a very primitive level. So it's just started. Okay, don't forget this, guys. It's been not more than 6 months. It started before 6 months only. concept of triggers. Even the lightweight transactions also started before 6 months. Not 6 months, I think I would say it as approximately a year. So, but still people started using it for the purpose of, to enable batching and then ensuring that, batch gets executed completely or not. So in case if there is an error, it gets rolled off. So which is most important, or which is the best concept which is available in RDBMS, which is not available within Cassandra. So, but there is a limitation. You should go with only smaller volume of data. Okay. So anyhow, I'll further move from the trigger. So we have again, like as I said, functions started coming up from the Cassandra 2.0, nothing but your CQL version 3. Okay. But again, it is not supported in the production, or it's not advisable in production systems. Okay. And it doesn't give you on key based functions, it supports only value based functions. Okay. On the key, you can't give a function and that gives a value what you want it. But on the key, on the value, you can call a function and it will return the one what it's needed, or the output of that particular function it can be returned. And we will talk about every individual function: token, time UUID, and blob conversion functions. A token is nothing but whatever you see token. For a given row key or for a given row key, it generates a token, isn't it? Based on different types of your partitioner. The same way, token function accepts your what's supposed to be your row key and what's supposed to be your partitioner. It will return its corresponding token corresponding to that particular partitioner. As you see here, the murmur3 partitioner will return a big int, nothing but your long integer. But whereas random partitioner will return only var int. That is the reason people prefer murmur3 partitioner rather than the random partitioner. The reason being is it is more bulletproofed to hold more volume of data. Let's assume every key has to be converted into every row key has to be converted into a token. When I say a big int, I may end up as list of tokens with 2 power some number. Am I correct? Which is supposed to be very long number. Whereas random partitioner, which is a variant, that is the reason there is a probability that it will end up with a less number of possible tokens. If your volume of data is too huge, it's better to go for a murmur3 partitioner. That's the reason with a new SQL or new Cassandra, default partitioner is murmur3. But if you look at 1.2 or older versions of Cassandra, you would see it as a default partitioner, as a random order partitioner. And then when it comes to byte order partitioner, the return it's going to return the blob. Okay, guys, it's going to return the blob. That is about a token or a token function. Indirectly, what it takes the key, what's supposed to be your row key, and it returns you what's supposed to become your token for that particular row key for a given particular partitioner type. Does it make sense? Can I get a quick response? Okay, guys. Next comes is uuid functions, because uuid consists even date as well. Okay, if you want to retrieve that particular date, then you can go for using time uuid functions. When you say now, it will give you the current timestamp based uuid. Okay, and then when you say date of, it will return you based on the date. Okay, and then Unix timestamp of will give you based on the Unix timestamp. Okay, So it basically to get the time UUID, these are the different ways through which you can get a time UUID at the time of insertion of data. Because if you see, you can't, let's say for example, salary, you can generate some, or you know what's supposed to be your data and you can generate it. But when it comes to UUID, you can't literally generate by yourself. That is the reason it has got a functions through which, with that particular help, you can create a UUIDs and you can fill your data. As I said, now function will return you the current unique new time UUID. Okay. The next comes your blob conversion functions. So nothing but your byte order partitioner. Whenever it is trying to write your data, okay, the token generated is a blob. Am I correct? So in case if you want to convert that blob back to your string or something like that, such sort of functions are available in the blob conversion functions. Clear? So that's about functions. As I said, I'm repeating, guys, don't use blob and clob, or not clob, functions as well as triggers within your Cassandra. So because it is not at foolproof, and there is a probability that it may misbehave and you may end up with a lot of troubles. Okay, so wait for at least minimum another 1 year before you start using functions as well as your triggers.